Welcome back my dear friends and dear students. This is the DADM, which is Data Analysis and Decision Making 1 course under the NPTEL MOOC series. And as you know, this is a 12-week course, total duration being for 30 hours, which is 60 lectures, because each lecture is for half an hour. And we are going to start the 41 lecture, which is basically starting, we have already finished 40, which is 8 weeks ago, we are going to start the 9th week. And each week we have, as I just mentioned, 5 lectures, each being for half an hour, and my name is Raghunandan Sengupta from IME department, IIT Kanpur. Now, if you remember, technically I am going to go a little bit into the past. Starting from the 29th, 30th lecture, we started studying the concepts of multivariate statistics, and for the multivariate statistics we took the concept initially for the different type of distributions like the multinomial distribution and the wizard distribution, multivariate t distributions, the multivariate normal distributions. Then we slowly covered all the concepts, and we also studied only related to the multivariate normal distribution, the concept of hypothesis testing, and the same basic concepts continue remaining as in the univariate case, that given the standard deviation we want to find out the mean. So, if the standard deviation is known, we just simply take the sample mean. Similarly, even if it is not known, the best estimate is still the sample mean, whether for the univariate case or the multivariate case. Then for given the mean value for the population, I am all considering the normal distribution, remember that. We want to find out something to do with the standard error or the variance of the sample, because we do not know the population variance. So, there can be technically two formulas. In the one case we use the S dash, another case we use the S without the dash, and it actually means that if the mean value of the population is known, we take that we do not lose any degrees of freedom, and we divide it by n and do the calculation. The formula is known, I am only highlighting in the main difference, and obviously inside the formula it will be basically a summation of, in the numerator, summation of the in the bracket xi minus mu whole square, because mu is known. Now, in the next case when mu is not known, the best possible course of action would be try to find out the best estimate of the population mean, which is the sample mean. So, as you use the set of observations x1 to xn for the first time and try to calculate the best estimate for the population mean, which is the sample mean, you lose 1 degrees of freedom. Hence, in the formula it is now it will be divided by n minus 1, and in numerator the actual equation would be summation bracket xi minus x bar n whole square, because that mu has been replaced by x bar n, which is the sample mean. Now, later on we saw, I am sorry I am going to go back a little bit more in the future, in the sense recapitulate whatever we had discussed, even though that may not be very relevant here, you will understand why I am doing that later on. So, given for the point estimation problems, we found out the best estimate for the normal mean, best estimate for the normal standard deviation for the population of course. Then given exponential distribution, we found out the best estimate for the parameter for the population. Then for the Poisson distribution we found out the best estimate, and obviously they were with proofs which we did not state, but the main contention of the analysis or the discussion was that you basically tried to analyze the unbiasedness and consistency. Unbiasedness being the case where you want to find out the expected value of the sample statistic or the sample characteristics with its distribution, such that in the long run the expected value is equal to the actual parameter value for the population. And the consistency means that as the sample size increases, observation number increases, the variance should basically tend to 0. So, what I mean by the variance, actually it would be the probability between the difference between the parameter value and the statistic value. As n which is the sample size increases, the probability slowly of the differences being less than equal to some epsilon. Epsilon is a very small value. So, it will always tend to 1, because it is both the values are equal. That means, the population parameter is equal to the sample mean which you are trying to utilize as the best estimate. Now, later on we saw that we are given in this was the crux of the point estimation. I will try to use the same ideas in the multivariate case also. In the interval estimation, we saw that they were basically 4 type of distributions coming out, and the why the consequence were that given the normal distribution, you want to find out something to do with the normal mean. Given the standard deviation of the population known, we took the z distribution, and obviously there was no concept of degrees of freedom. Then we found out that, and we gave the logical sequence of the understanding was that given the population variance is unknown, and yet you want to find out something to do with the population mean, we took the t distribution, and the t distribution had n minus 1 degrees of freedom. The question is why n minus 1, and because the t distribution coming for the case when, as I have just mentioned, the population variance being known, but you unknown, but you want to find out something to do with the population mean. And this degrees of freedom, as you know, is basically coming from the fact for s dash and n's without a dash. Now, these two formulas related to z and t would always be utilized when we are trying to do some studies or go into the depth of analysis of some problem related to the population mean and the population variance or the standard deviation. Being given in the first case standard deviation being known, and in the second case standard deviation being unknown, that means z and t. Now, if you want to find out something to do with some studies related to the population variance, so again there would be two cases, population mean being known and population mean being not known. If the population mean is known, then obviously you will use the chi-square with n degrees of freedom when there is only one population, and if you want to basically compare two populations standard deviations, and if both the mean values of the population 1 and population 2 is known, we will use the f distribution with m comma n, m being the number of observation in the first population, n being the number of observation in the second population. So, it will be f with degrees of freedom m comma n. Now, when we want to find out something to do with one population, its standard deviation on the variance, and the population mean is not known, then we know that we will be utilizing the chi-square with n minus 1 degrees of freedom. And when we go into the realm of trying to understand the two different populations corresponding to their population variance, given the population mean values are unknown, then we will use the f distribution again, but the degrees of freedom would be m minus 1 n minus 1. The m minus 1 being fact that we are losing 1 degree of freedom from the first population, and n minus 1 being the case when we are using the degrees of freedom for the second population. So, this concept would come, and the corresponding distributions which we have for the t, we had the student t distribution multivariate case, then the wizard distribution was basically replacement of the chi-square which we discussed. And if you remember, I did mention very fleetingly, though it is absolutely true, that as we utilize the concept of the sample mean and the sample variance are independent for the case of the normal distribution, this will continue to be true in the case of the multivariate case also, which means the wizard distribution and the mean value wizard distribution corresponding to the standard deviation. Then later on we came into trying to utilize different other distribution, that means the Poisson, the exponential and hypergeometric other things, considering the sample set of observation is large, and we can easily replace them their mean values, those distribution mean values and the variance in the case with the normal distribution, and still continue with our work. Now, this was also true in sense for the normal case for the multivariate distribution, and the multivariate distribution we did discuss the simple examples of multinomial distribution and all those things which we have seen. Now, later on we found out that after the proofs and few of the results, we went in the concept of Coppola theory. Coppola theory is basically the linkage function which you want to find out using the marginals and the joint distributions of the random variables x1, x2, x3 and so on and so forth, and we consider you have basically p or k number of random variables and you want to find out what is the Coppola linkage. It is basically a marginal distributions concepts. And obviously, Coppola comes into the picture when we want to find out something to do with the independent structure at the extremes. I had drawn that, if you remember. Now, when we come to the in the concepts of trying to find out later on for the independent structures, the first different type of ideas we considered was basically the principal component analysis. Now, the principal component analysis which we went a little bit slow, and I would really like you to understand that this was the first case that we are basically going through only the formulas and trying to basically utilize these formulas, not derivation, the concepts and try to utilize them for the problem solving. So, the main idea was basically in principal component analysis you are given a set of data and some random variables x1 to xp, and we will consider the x1 to xp are not independent of each other, they are as independent structures. So, obviously, they would each of them would have a mean value, each of them would basically the combined variance covariance matrix. Now, our main question would be that is it possible to find out a certain set of convex combination of this random variable x1 to xk or x1 to xp such that we can find out the maximum variability step by step and basically formulate those variabilities in some orthogonal direction to each other such that we are able to explain the variability to the maximum possible extent using the combinations of x1 to xp which are all orthogonal to each other. So, it looks absolutely perfect conceptually, that means we want to basically break the dependence of the variability into orthogonal direction. And obviously, the next question would come that how you are going to do that. We will take basically the variability for the case which is the maximum, then the next level and the third level, fourth level we will go on and so on and so forth. So, obviously, it becomes very intuitive that why not basically break those principal components in the orthogonal direction using the concept of eigenvalues and eigenvectors. Now, the eigenvectors would basically give me the so called values depending on the eigenvectors which I find out. The cell values will give me that in what combination I should combine x1 to xp such that I am able to get the first principal component which is y1, then the second principal component which is y2 and so on and so forth till the pth one. So, obviously, these y1 to yp would all be independent of each other and we can find out what is the variability. So, the variability is found out, and when we find out the variability of y1 or y2 or y3, then we calculated, obviously those will be calculated using the variance covariance matrix which I have for x1 to xp. We find out the variability was equal to the eigenvector values, and obviously they would give us the information that the orthogonality actually the breakages of the orthogonal vectors of y1 to y2 to y3, y4 are all right. And also we found out what is the variability. So, the variability of the actual variance for y1 would be highest, then the y2 and y3, and it will decrease, continue decreasing. We use this example for a 3 by 3 matrix and basically proved the orthogonality, the concept of how eigenvalues and eigenvectors would be utilized. Later on we came to the factor analysis. In the factor analysis, what we are trying to do, which we will continue discussing now on further also, we will continue that the factors are decided such that we will break them into two parts. One are the factors which are basically have their effects, and one would basically be the white noise. Now, we will also consider that white noise concept we did not actually consider to be existing in the, even though it was existing, we basically assumed that they could be ignored. In the factor analysis, we will try to utilize the concept of the factors along with an error terms and basically proceed accordingly. Again, the same concept of the eigenvalues and eigenvectors would be used. The eigenvectors would be denoted by lambda 1, lambda 2, lambda 3 till lambda p, And obviously, the eigenvectors direction would be given by the bold E1, then E2, then E3, E4 and so on and so forth, where E1 would basically be the eigenvectors corresponding to lambda 1, E2 would be the eigenvectors corresponding to lambda 2. Now, we were basically discussing that, we will come to that later on. I am sorry that I had to basically recap all these things, because the concept which are being discussed may be a little bit intense. So, I thought I will go a little bit slow in order to basically clarify the points as may be necessary for the students. Another point which is also nothing to related to the this course directly, but technically this being a 12-week course which is about 60 lectures 30 hours. So, we will basically have a one-to-one session with the students and the instructor, which would be me, and obviously there would be queries, and we will try to basically split the set of queries which would have been basically after the first 4 lectures, then next 4 lectures and so on and so forth, which is 4, 8 and 12. But after the 8th lecture which you have started, obviously there would be a weekend or a weekday in the evening, where based on the communication which will be sent from the NPTEL office, I will definitely be available to answer queries both for the first 4 set of lectures and the next set of 4 of lectures, which will basically 8 lectures. And then depending on how your queries and whatever the queries in the forums, we will basically try to tackle all the queries which may be coming up both from theoretical point of view as well as the practical point of view. And then at the end of the 12th lecture, we will have the third session of one-to-one video conferencing, and I am sure in both considering the assignments which will be 12 in number, also the 3 different 1 hour sessions, minimum of 1 hour sessions which we plan to have with the students for the first 4, then the next 4 and the 12th one, 12th lectures. I am sure, and also obviously there would be 12 assignments. So, this is the 8th week starting. So, you will definitely have the solved at least 7 set of assignments, and by the time when you are basically coming for the one-to-one sessions, you definitely would have received the 8-week assignments, and after they are solved, you can definitely have queries accordingly. So, the reason why I am spending so much time in the first part is basically to discuss what we have covered, and the next part in order to basically tell how things will be handled from our end in order to answer the queries, was because in the forum there are many different questions which are coming up, which may be a little bit easy, but unfortunately due to either paucity of time from your end or the way the whole concept of the course, considering that a huge set of coverages are to be done, due justice has to be done from your end, in the sense that spend some time with the concepts, clear out doubts related to the books. If you remember, I have given you a lot of books and the references, and still if you are not able to do that after solving the assignments and trying to basically get your queries answered in the forum, and also after the one-to-one session video conferencing, still if you have some questions, you are most welcome to basically collate them and send on the forum. We will definitely take our time out and answer all the related questions which may arise for this course. Okay. So, I am basically continuing with the factor analysis. Sorry for a little bit more exhaustive introduction and what things we should be planning in order to basically cover the course in a much better way. So, let me read it for the factor analysis. I have come back to the course. So, if the number of common factors, that means the factors based on which we will try to basically do the analysis, is not known beforehand or is not determined a priori, one can use the knowledge of previous researchers. So, the set of information which will be there from by the previous researchers can be utilized in order to answer the question. A thumb rule is to find the value of the residuals in the matrix S. S, if you remember, is the variance covariance matrix from the or the square root of that from the point of view of the sample, because we are nothing to do with the population. So, L1, L2, L3 till the values of L, which will basically be till m, because we are taking m out of the p number of such factors. So, they would basically would have 2 sets, one is the known level of dependence, one is the white noise. So, that should technically be in the long run if the divisions of the amount information so called how should I put it, information being relevant from the point of view where you are able to give the reasons for those aberrations and one set of white noises for which you are not able to give the informations. So, they should technically be equal to the sum of the eigen value square. So, a small value of the sum of the squares of the neglected eigenvalues means a small value of for the sum of the squares errors of approximation. So, obviously depending on the problem we are able to answer it or not will come out from that value. The contribution to the total sample variance would technically be, if you consider the principal diagonal. So, the first value would be S11, second one would be S22, which is basically the counterpart from the population. If you remember, it will be sigma 11, which is the covariance of the first with respect to itself. Then the 2 comma 2 element would be sigma 22, which is basically S22. So, sigma 22 is basically the covariance of the second with itself, until the last element which in the principal diagonal will be SPP, which is basically sigma PP, which is sigma, all these are suffixes, sorry, my mistake. So, which are basically the covariance of the pth vector with itself. So, so this the total sample variance, which is S11 plus S22 plus dot dot till SPP from the ith common factor is given by this I. So, these are basically coming out from the values of the lambda. So, they would basically be given by I square I1 square plus I2 square plus I3 square till I p square. So, p is in the suffix and the squares are on the p's are in the in the base, and they would basically be power the square. So, they technically they should be equal to the values of lambda 1 plus lambda 2 plus lambda 3 multiplied by the square root of them multiplied by their eigen vectors, and that should basically be equal to the lambda I. So, obviously, they are the estimated value. Thus, the proportions of the total sample variance due to the jth factor would be given by the ratio of the eigen values divided by the sum of the principal diagonal, which is S11 till SPP, such that depending on whether it is to do with S or R. S would basically be corresponding to the case when we have the sample, and R would be the case when we have corresponding to the population value. So, the R, what I am saying is that population means that I have the counterpart from the population, which is the correlation coefficient. So, based on that we can basically do the calculations. So, what is the general plan of working for the factor analysis? So, what first we will generate a variance covariance matrix of the observed variables, that is S, which is basically the estimate of summation or the mu value, and this capital mu value is basically the variance covariance matrix of size p cross p. Once we have that, we will basically select the number of factors, that is out of this p, obviously m would be less than equal to p, by finding out the lambda hats. So, lambda is basically vector, and which is the eigen values, and e's, bold e's are basically the eigen vectors. So, technically the E1 value would be corresponding to the first element of the first vector, then corresponding to the second value would be in the first eigen vector would be basically E12, then E13, E14 till E1p. Then similarly, we will basically have E2, E21, E22, E23 to E2p, where the first value here would basically be corresponding to the eigen vectors, which is the second level and for lambda 2. Now, with respect to the estimates from the sample size n, we get it in general trying to find out, as I mentioned, lambda hats mean basically the estimates divided by the sum of S11 till SPP would be utilized when we have basically the standard error of the sample, and in case we want to basically divide by the value of p, that means summation of lambda j is divided by p would be coming out when we have basically the correlation matrix corresponding to the sample. So, we will extract our initial set of factors, and based on that we will try to find out f1, f2, f3 until fm. Remember that what we are trying to do is that trying to utilize a set of factors m which is less in size with respect to p, and utilize them in such a way that we get the maximum amount of information which is plausible, and the other type of white noise would basically be putting into the error term. We will perform the factor rotation to a Terman solution. So, basically we will standardize them, rotate the factors as that they would be orthogonal to each other. Again the same concept being taken up, where we try to utilize the set of information which is coming up from the eigenvalues and the eigenvectors. And rotations are being done such that the maximum variability plausibility is there, and once it is for the first set is fixed, we will basically keep that and then try to find out the rotation of the second set with respect to the first, that they are orthogonal to each other. So, we will keep rotating it in this way such that each of them are orthogonal, and the variabilities are basically being subsumed or coming out from the discussion of factors which are m in number. M, if you remember, is less than equal to p. So, once we find out the factors, so we have the variance covariance matrix from the sample which is S, and that would basically from that we will try to basically subtract two sets of information. One set of information with the factors information which is plausible, and for which we do have some formulas to say that yes, the factors are coming out from the m number of so called vectors corresponding to the lambda, those eigen values lambda 1, lambda 2, lambda 3, and obviously the eigen vectors would be there given as E1. E means all these are capital E1, E2, E3, and they would basically be a set of white noise which we will try to basically capture using the P cross P matrix of capital phi. So, once we construct this, we will basically have now in this case of the principal component, we have the principal components such that they are orthogonal to each other. It had nothing to do with the error terms, but now, and obviously the convex combination were being utilized because we consider the relationship was linear. Based on this we proceeded. So, we will consider the cost factor scores in such a way that the first set of factors which we have would basically be the convex combination corresponding to the first factor, which will be L11 into F1 plus L12 into F2, so on and so forth, till the mth one, which is L1m into Fm. So, this whole set which will we have, this will give me the plausible reasons which are for which I can assign reasons, and this would be the error part. Similarly, when we go to the second one, it will be x s so if I have this and highlight, this is the error term, this is all the error term of the pth one, and the factors for which we will have the information is for the second, for the first, and for the last one. So, we are trying to divide the overall the variance covariance into two parts, the variability. One are the factors which are plausible, and one is the white noise. So, with this I will close the 41st lecture and continue discussing more about factor analysis and multiple linear regressions later on. Have a nice day and thank you very much.